literature review. Now, the three web services that we have reviewed are Amazon Web Services, Microsoft Azure, and Google Cloud Platform. Let's take a look at Amazon Web Services. Now, Amazon Web Services is a subsidiary of Amazon. As of 2021, AWS has over 200 products and services, including computing, storage, networking, database, analytics, application services, deployment and management, developer tools, and tools for the Internet of Things. As of 2021, AWS has distinct operations in 25 geographical regions, 80 availability zones, 108 direct connect locations, and 245 countries and territories served. And it also offers pay-as-you-go approach for the pricing model. Moving on to Microsoft Azure. Microsoft Azure launched in the early February 2010. Some of the cloud services offering were virtual machines, object storage, content delivery networks, the remotely hosted managed versions of proprietary Microsoft technologies, and open technologies such as various Linux distribution deployable inside a virtual machine. Azure have 54 regions worldwide and is available in 140 countries all around the world. Azure also offer up to 60 services. Azure also offer pay-as-you-go approach pricing just like AWS. Moving on to Google Cloud Platform. It has been around since 2011. Google Cloud offers a robust and highly available architecture based on 24 regions and 73 availability zones. Google Compute Engine implements an abstraction layer between availability zone and physical cluster of machines in Google data centers. Google Cloud Platform also offers a pay-as-you-go pricing structure. Users only need to pay for the services that they use, and that is all for literature review.
I will now present the comparisons of cloud technologies. The three cloud technology platforms we have chosen to compare are Amazon AWS, Microsoft Azure, and Google Cloud Platform. In terms of pricing, among the three cloud vendors being compared, Amazon AWS platform is the most worth it in the long run among the three platforms. In terms of operational years, Amazon AWS has also been around for the longest time among the three cloud vendors. For this project, Amazon AWS was chosen to be implemented as we could make use of its free tier services provided by AWS. This allowed us to make use of the services we required with minimal costs. For cloud storage, Amazon AWS uses Amazon S3 storage, Microsoft Azure uses Azure storage, and Google Cloud Platform uses Google Cloud Storage. Google Cloud Storage has the fastest data retrieval among the three platforms, and Google also has the least expensive storage costs in terms of the three platforms. For image recognition services, Amazon AWS uses AWS Recognition, Microsoft Azure uses Microsoft Cognitive Services, and Google Cloud Platform uses Google Cloud Vision. All three platforms provide features such as image tagging, video tagging, emotion detection, and so on. But only Google Cloud Vision can support Feedback API. For serverless computing, Amazon AWS uses Lambda, Microsoft Azure uses Functions, and Google Cloud Platform uses Cloud Functions. In terms of handling workloads, AWS Lambda is the best, being able to handle up to 1,000 functions executing concurrently. In terms of scalability, auto-scaling is also available for all three platforms. For the database, Amazon uses AWS DynamoDB, which supports the most programming languages, such as Python, JavaScript, Java, and so on. Azure uses Cosmos DB, and Google Cloud uses Cloud Data Store as their database service. All three platforms can be accessed using API, but Cosmos DB and Cloud Data Store both support MapReduce. Cosmos DB and Cloud Data Store both support MapReduce, which makes them capable of processing large datasets parallelly, which are distributed across multiple nodes. For messaging, Amazon AWS uses Amazon SNS, Microsoft Azure uses Azure Notification Hubs, and Google Cloud Platform uses Firebase Cloud Message, FCM. For IoT platform, Amazon AWS uses AWS IoT Core, Microsoft Azure uses Azure IoT Hub, and the Google Cloud Platform uses Google Cloud IoT. Security-wise, AWS IoT Core and Azure IoT Hub are more secure than Google Cloud IoT when accessing IoT services due to the authentication features. For analytics, Amazon AWS uses AWS QuickSight, Microsoft Azure uses Power BI, and the Google Cloud Platform uses Google Data Studio. AWS QuickSight is compatible with many different data sources such as SQL servers, Apache Spark, Amazon Redshift, and so on, while also including autograph features. This means that based on the data provided, it will learn and provide recommendations on the type of graphs that can be plotted with the data. That's all for the comparisons. Thank you.
Hi, my name is Taizushi. I'm going to talk about the problem statement. In today's world, road traffic collision have risen to become the leading cause of injury, death, and the 10 leading cause of all fatalities. Developing countries bear a large share of the burden, accounting for 85% of annual deaths and 90% of the disability-adjusted life years lost because of road traffic injury. Many road accident victims have died as a result of their injuries because they were not taken to the hospital and treated in a timely manner. Furthermore, in some situations, drivers on the road may be unaware that an accident has occurred in front of them. Due to this, they drive on as usual while being ignorant to any accidents that have happened up ahead, which can result in them braking suddenly upon noticing the accident, leading to another car crash. This will result in even more tragedy. Now, I will be presenting the objective. In this world of information technology, cloud computing is the current buzzword. It refers to a situation in which a company data and applications are hosted on a third-party infrastructure such as AWS, Google Cloud, and Microsoft Azure Cloud. Nowadays, the growth of IoT and cloud technology has reached a stage where it is mature enough to be applied in society in a widespread range as technology progresses over the generation. The cloud application has grown to include a wider range of services, and each of the services can connect to one another seamlessly. The aim of our project is to develop a cloud-based solution for implementing a smart street light that will serve as a surveillance camera and an incident recorder. The smart street light has a camera as the IoT device that can send the footage to cloud services to be stored and reviewed. The cloud services will analyze the footage, assess the occurrence of the incident, and if an accident occurs, it will notify the necessary emergency parties such as law enforcement, medical professionals, rescue squad, and the authorities. No, not only that, the smart street light will also change the color of the light bulb once it detects an accident to alert other drivers on the road so that they are aware of the accident in front of them and slow down to avoid more accidents. In our proposed solution, we have selected a few services provided by Amazon Web Services AWS, which consists of AWS Recognition, IoT Core, S3, AWS Lambda, SNS, and DynamoDB. The main input for our proposed solution is from the camera, which acts as an IoT device that is capable to connecting to the internet and transmit the captured image of a specific location to other cloud services. The captured image will then be stored in the S3. A Lambda function will be invoked every time when the S3 receives a new input. It will send the captured image to the AWS recognition to review if an accident has occurred. The recognition will analyze the image and send the result back to the Lambda function. If the image is identified as an accident, another three Lambda function will be invoked to store the details of the accident into DynamoDB, change the color of light bulb, and send notification to the authorities through SNS. Lastly, the AWS QuickSight is used to visualize the information in the DynamoDB such as the total number of accidents, monthly accidents according to location, total accidents by year, and total accidents according to location.
Good afternoon, sir. My name is Neotitin. Now I will discuss the function of each service in our architecture. The first component that exists in our architecture is camera. There are multiple cameras are installed on the smart street light in different regions to capture the image of the road in the interval of 1 minute and send it to the Amazon recognition to detect the occurrence of the road accident. The second component implemented in our architecture is Amazon S3, which is used as the object storage for the captured image. The captured image from the multiple cameras are stored in the Amazon S3 before sending to the Amazon recognition to detect accident. Amazon S3 is selected as our image storage because it is secure and provides high data durability. It also keeps the image from errors, failure, and threats and made it available whenever it's needed to be accessed. The third service we have used is the Amazon Recognition Custom Label. This custom label service is implemented to detect the occurrence of the accident from the image capture. Since this is the custom label service, we need to train the model by feeding the accident sample image to the model. So once the model is trained, it's now ready to predict the traffic accidents based on the given road image. Besides, we also include AWS Lambda in our solution. The first three Lambda connected to the camera are used to distinguish the location of each image capture. And then the Lambda connected to the S3 bucket is triggered to perform the recognition once the image capture are sent to the S3 storage. When the image is predicted as accident, then three of these Lambda will be invoked asynchronously to change the light color to red and store the details of the accident image to DynamoDB and send notification to authorities. On the other hand, when there is no accident predicted, the Lambda that is responsible for changing the street light color will be invoked to change the color back to the original state. Proceeding to the next service, DynamoDB is used to store the details of the accident image, which are image ID, bucket name, location of camera, and timestamp. The purpose of the record is to enable the authorities to verify the correctness of the accident that were predicted by referring to the image stored in the S3 bucket using the image ID and bucket name. We are using DynamoDB because it provides benefits such as auto-scaling, in-memory caching, backup, and restore option. Amazon SNS is a fully managed messaging service for both application-to-application and application-to-person communication. In order to inform the relevant authorities, such as law enforcement, medical professionals, and rescue squad, we decided to use the SNS as it can coordinated by the Lambda function to trigger what message should be sent as notification. We can add the relevant authorities as a subscriber to the SNS, so they can receive an immediate alert from the service when an accident is detected. Furthermore, we also implemented AWS IoT Core in our solution to provide cloud service to the devices connected to it, such as camera, computer, and light bulb. AWS IoT Core supports a protocol such as MQTT, HTTPS to send a message between the IoT device and IoT core. Both the IoT device and IoT core can subscribe to the topic in order to listen for MQTT message or publish to the topic to send MQTT messages. Lastly, we also implemented the Amazon QuickSight to visualize the data easily with the interactive dashboard. QuickSight enables the authorities to perform analysis and visualization from the data collected and make a better decision from the generated dashboard. In order to visualize the DynamoDB data in QuickSight without duplicating the data to another data source, we set up a data connector in Athena that could actually view and query the DynamoDB data without any custom code.
Okay, so we are group 12. Now we're going to be showing a demonstration of the overall solution. So at the beginning of the solution, for an actual implementation, there will be cameras that will be taking pictures of the streets from the streetlights and like at certain intervals and then sending it to the S3 bucket using a Lambda function. But since it's just for a proof of concept, right now for our flow, we're going to be throwing the images into the S3 bucket straight as the beginning of the whole flow. Now I'll pass it over to my teammate Neo Jichin to continue the demonstration of the flow.
Now I will show the beginning of the flow. First, we will upload the picture into the bucket and then the recognition lambda will be triggered to perform the recognition. We will start with accident picture and then upload it. Once the picture is uploaded to the bucket, this recognition lambda will be triggered to invoke the three AWS lambda asynchronously. And then now we will show the result.
One of the lambda functions that was invoked by the lambda function with the recognition was if the accident is detected, then it would ask the light bulb to be changed to red color. Later, we will show another demonstration when an image is uploaded and an accident is not detected, it will get changed to green color. I will now pass it over to Zishi to show the DynamoDB.
Now I will be presenting the AWS DynamoDB part. Once the recognition detected that there is an accident occur, it will invoke the store record lambda function. The details of the new image like the ID, the bucket name, the location, and the timestamp will be stored into the DynamoDB. Yeah, and then this is the new record.
When an accident is detected, three lambdas functions will be invoked. Now I'll show you what happened in the SNS side. So the authorities will receive an email regarding the accident. As we can see here, we have a AWS notification regarding accident alert. In this email, as we can see 6 minutes ago, we will get details regarding the bucket name and the video name. This will allow the authorities to easily find the detected images or videos. For our current implementation and for our proofing of concept, we are just using email right now. But in the future, if this were to be implemented, we'll be using something more fast-paced like SMS, something like more instant.
Now we will repeat the process by uploading the picture that's not an accident. So again, the recognition lambda will be triggered, and this time only the change light lambda will be invoked to change the light to green. Now I'll pass to Dennis to show the result.
So as was mentioned earlier, when the image passed into recognition does not detect any accidents, then it will ask the light bulb to change back to green.
In our case, we use Amazon QuickSight to visualize our data in DynamoDB. This is how our dashboard look like. This is to show the total cases, and this line graph is to show the total accident by year. This histogram is to show the count of records by month and location, and lastly, this pie chart is to show the monthly accident according to location.
That's the full flow of the solution. Thank you.